Hello. My name is Raphael Mechoulam. I'm a chemist, and I work on natural products produced by plants, natural products produced by our body. And one of the topics that we've been looking at is cannabis. We started working on cannabis about, 50 years ago. I was surprised to find out at that time, when I initiated the project, that cannabis had not been well researched. While morphine had been isolated from opium 150 years previously, and cocaine had been isolated from coca leaves about 100 years previously, the active compound or compounds in hashish and marijuana had never been isolated in pure form. The structure was unknown, and therefore, from a modern point of view, one could not do work in not only in chemistry, which of course is important, but also in pharmacology, physiology, and then go to the clinic. Modern science requires that. So we started work in 1963, 1964. Our supplier was the police. Actually, we called, or some of the institute where I worked called the police and asked whether they can supply us with cannabis. And I heard from the other end somebody asking, is he reliable? And actually, the administrator, who barely knew me, said, of course he's reliable. So I went to the police and got 5 kilos of hashish. And then it took the hashish with me on a bus. I didn't have a car then. And people were looking around saying, hey, what a pleasant smell. So then it turned out that we had broken the law. The police was not allowed to give it to me, and I was not allowed, of course, to take it from them. But, they said the Ministry of Health has to approve it. Well, so the Ministry of Health was very nice, especially those that were my ex-students. So they allowed me to get cannabis again and again, and I acknowledged the police in my scientific paper saying, thanks to the police for supplying the cannabis. Well, we started working, and I actually asked for a grant from NIH. I had grants from NIH on other topics. And I said, no, nobody's smoking marijuana in the States. We know that people in Mexico use it, not in the US. Well, just a couple of months later, a year later, the head pharmacology of one of the institutes called me. It turned out that somebody important, maybe a senator, his son had been caught smoking pot, and he wanted to know whether it's destroying his brain. Now, they had not given a single grant to anybody on cannabis. Nobody knew there much about it, and they recorded a young fellow, remember that's about 50 years ago, a young fellow from Israel had asked for a grant, so they flew over, and by that time we had isolated the active compound, tetrahydrocannabinol, THC, elucidated its structure, and actually synthesized it. So we had 5 to 10 grams, the world supply of THC, and they took it over, smuggled it, and for the next about 45 years, NIH was happy to support my work. Now, what did we do with cannabis? First, as I said, we had to see to isolate the active compound, which we did. Then we found out that there are quite a lot of other compounds. Today we know there are about 100 cannabinoids, or compounds of the same type, that are present in the plant, in the cannabis. But only THC is active, and in this sense, and causes the known activity of cannabis. There are many other compounds. The most important other compound which we elucidated the structure of is cannabidiol, which does not cause these things, but it has turned out to be an outstanding a compound in a lot of diseases. And so over the next years, a few years, I'm speaking of the late 60s, early 70s, mid 70s, we worked on the chemistry and pharmacology, physiology, and started clinical studies. One thing was not known at that time. How does THC work? Well, in quite a few years later, we found that THC actually mimics something that we produce, that our brain makes. And this compound that we produce, we called it anandamide. We called it anandamide because in Sanskrit, ananda is supreme joy. We tried to find a good Hebrew name, and, well, it seems that we know how to be sorrow, not so much how to be happy. So, but ananda in Sanskrit means real happiness. Anyway, we call the compound anandamide, and this compound binds to specific receptors in the brain, specific molecules in the brain that when they are stimulated by the compound that we produce, start all the effects that we know about cannabis. THC, the compound that's present in cannabis, and which we had looked into years previously, mimics the effects of compounds, two compounds, which were isolated at that time. It mimics the effects. So there has been a huge amount of work on both on THC, both on cannabidiol, and quite a lot on the endogenous cannabinoids, the endocannabinoids. So there is a system now, a biological system, which is named the Endocannabinoid System, and it is involved in a huge number of physiological states. As a matter of fact, a recent review by people from NIH, recent review stated that the endocannabinoid system is involved in essentially all or almost all human diseases. Now that's a very, very strong statement. I don't know of any other system that one can say that. Well, even if it is not fully correct, it's correct to a lot, well, it is nearly correct. And if we look at many diseases, this is what happens. It is involved. How is it involved? Sometimes it acts directly on one of the mechanisms in that disease, but it also does something else. These compounds affect the release of neurotransmitters, of other neurotransmitters. So it acts not only by itself, it also acts by affecting other neurotransmitters. And so that's why these compounds have turned out to be of such an importance. Now today, both THC and cannabidiol are considered medicinal agents. THC is used, not widely, but it is used to suppress vomiting and nausea during cancer chemotherapy. We did that with children about 20 years ago. Unfortunately, children get cancer as well as adults. And they were in a bad shape. They were getting drugs that were causing vomiting and nausea, and they were crying all the time, and quite a bad situation. And we started giving them small amounts of THC in olive oil under the tongue or on the salad they were eating. And we were surprised, really surprised to see that essentially all children stopped the vomiting, stopped the nausea, and felt okay. And this was published, but it took many years until other people started using it. Another example, and this was with THC, with a compound that causes the high. But cannabidiol is even more important. We did a clinical study on epilepsy. We had about 15 epileptic adults, and we gave them cannabidiol at high doses after doing a lot of work on mice and rats and all kinds of other things. And we found that, yes, cannabidiol at high doses, 200 to 300 milligrams per day, really blocked to a large extent the epileptic attacks. Half of the patients did not have any attacks, half of them had very, very few attacks. Well, that was published in 1980, which is so many years ago. It took another 30 years for this publication and knowledge that something like that is happening for physicians in the US to start advising their patients, go to Colorado, where cannabis is free, or more or less free, and take cannabis that contains a lot of cannabidiol to help your children, if children had that kind of disease. And today in Israel, we have, I believe, about 120 children that get cannabis with very high levels of cannabidiol and very low amounts of THC, and it helps them tremendously. They don't have 20 attacks a day, they may have 1 attack a month. So here we have something that's already helping human patients. But unfortunately, there are a lot of diseases where we know from animal studies that may possibly, in particular cannabidiol, can help. There is a large group of diseases called the autoimmune diseases. The body, for various reasons, attacks itself, attacks its own cells. And for example, diabetes type 1. This is one of the 2 types of diabetes that exist. In diabetes type 1, the body attacks the cells that produce the insulin, and the child, it's called a pediatric disease, and it destroys the cells that produce the insulin. But in animals at least, and in animals the mechanism is exactly the same. In animals, it works very well. We can reduce that kind of disease by 70%. And yet, it has never been tested in humans. Why not? I have no idea. We cannot do it. I mean, after all, university is not built to do clinical trials, and so on and so forth. The same is true for schizophrenia. We showed it in schizophrenia, it works. And there was a large clinical trial in Germany and showed that cannabidiol, which affects 1% of the population throughout the world, cannabidiol is as good as the drugs that are being used today, but it causes no side effects. And yet it's not being used. Well, but we have gone ahead, and it turned out that our body produces a large number of compounds which chemically are closely related to anandamide. So we ask, why does the body do that? After all, our body is lazy. It doesn't make things because it has nothing else to do. So we started looking at these compounds, and of course I won't go into details, we don't have time, but we found that one of the compounds lowers damage, brain damage. Somebody has undergone brain damage, the body starts producing compounds of this type and lowers the damage. We found that another compound acts on osteoporosis. Women after the age of 50, 55, all of them should have osteoporosis. Well, that's not true. Some of them do, but some of them don't, because of the hormonal changes. Now, why don't all women have osteoporosis? Because the body, in many of them, in most of them, produce another compound of this type, cannabinoid-like compound, which we produce, and it blocks the osteoporosis. And some work that we just published over the last few weeks is addiction. Most work that has been done on addiction has been done on the addicted people. But actually, one should look also at people that do not get addicted, although they use drugs, nicotine, cigarettes, whatever, they are not addicted. Why aren't they addicted? Well, addiction is a disease, so we started looking at how does the body attack the disease? How does it try to prevent it? Well, after quite a lot of work, and that's work by 4 collaborating groups, we suggested, but we couldn't do most of the work. It was done by our group, a group in Virginia, a group in Canada, a group in Italy. We sit together at meetings, drink a lot of coffee together, and we discuss how to go ahead, and we just published the first paper. We found that our brain produces a compound that blocks nicotine addiction, maybe also blocks the withdrawal effects of heroin, and other opiates. So there is a lot of promise in this endocannabinoid field, and I hope that more work will be done, both with the plant cannabinoids, cannabidiol, THC, more work with the compounds that we produce in the brain, and more work with the compounds of the third type I was describing, which seem to be involved in a large number of additional diseases. Thank you.